Hello, welcome to my session. The title of this session is Deep Dive into InnoDB from Redo Log perspective. In this session, I will illustrate three things: the overview of LY Corporation, the company I work for, and second, the overview of MySQL platform in my company and how we manage the MySQL environment. And lastly, the third, I will explain the passion to do a deep dive into MySQL inside, which is important for stable operation of our large-scale MySQL platform. Before talking about the actual contents, let me explain myself. I'm Tomoaki Otsuka, also known as Tombo on the internet, and one with a dolphin in Japan, having a jet lag. And I'm working as a DBA and database engineer at LY Corporation. And I like reading and analyzing MySQL logs, like binary logs and redo logs and MySQL networking protocols, and developing tools for operation. Now, let me introduce our company. Our company, LY Corporation, was formed last year due to M&A of 5 companies, including LINE and Yahoo Japan Corporation. Formerly, I was working for LINE Corporation, a popular messaging service company in Japan and Asia. LY Corporation are providing many services, including a popular communication service, LINE, and the comprehensive internet service, Yahoo Japan. Here are some of the numbers describes our companies. We have millions of monthly users. For example, X-LINE company have 196 million monthly active users, and Yahoo Japan has 54 millions of active monthly users. And our mission is to deliver wow experience to our users with our services. And most of our services are using MySQL as a backend database. And I'm pretty sure that it's obvious for us in this room, but why we choose MySQL? It's because an open source, and thanks to InnoDB, it's highly reliable and also fast for OLTP workloads. And the capability of online DDL and rolling scheme upgrade is very helpful for us, providing 24/365 internet business. And there are great user community, and I learned a lot from you and community. Now, let me illustrate MySQL environment at LY Corporation. Most of our services are running with MySQL as a backend database, and we provide MySQL as a DB as a database as a service in our private clouds. And we run MySQL instances with virtual machines and physical machines. And the instance type is ranged from 4 vCPU to 40 vCPU, and 8 to 256 gigabyte memory. And the storage is ranged from 100 gigabyte to 6 terabyte on SSD. And we run MySQL, and for HA topology, we mainly use semi-sync replication. And we started to use group replication a while ago. And also, Yahoo Japan used PXC, Percona Extra DB cluster. So half of them are running with PXC. And total instances are 12,000 instances. So that's a little bit huge platform. And thanks to official and community third-party tools, we can keep our MySQL highly reliable. And for HA, we use Orchestrator and in-house high availability solution. And also monitoring, we use Prometheus and Grafana. And for DDL operation, we use Ghost and PT Online Schema Change. And combine them, we developing in-house safe DDL tools, which is named Safe DDL. And for backup, we use Clone plugin, extra backup, and MyDumper, MyLoader, and also dump instance command with MySQL shell. in case by case. And also utilities, we use MySQL Shell and Percona Toolkit and MUH. And MUH is another powerful in-house tool that is MySQL Upgrade Helper. And this tool powerfully supports the migration and upgrade operation automatically. And my colleague may introduce those in-house tools in COSCUP conference in the conference in Taiwan in this summer. So please check it out if you're interested in. And also, we are developing those automation systems to reduce costs. And also, we can reduce human errors and avoiding complicated operation in each environment. But sometimes we face some mysterious issues on large environment and also high load environment. For example, in this case, we are running with MySQL 5.7 replicated with semi-sync replication. And there is two big schema database, which is S1, and S1 has many tables and still have many dirty pages on buffer pool. And I dropped this database, S1, that hangs the another schema, S2. And this hangs caused by dict-sys mutex triggered by semi-sync replication. I do not explain details because this will not happen in 8.0 and later. But to investigate and prevent those scenarios, it's really important to understand MySQL internals. But it's also really hard to understand the implementation of relational database with 30 years history. So how do we understand MySQL internals? I'm still wondering how to, but it's because it's really hard to understand the architecture by simply reading the source code. But I'm sure that some folks are trying. For example, InnoDB Ruby project describes the InnoDB data structure very well. And also, the MySQL Ace Pro in Japan, Yoku 0825, introduced the how to investigate the implementation with error log information. And I admire them, so I've started the journey to the core from Redo Log. Because Redo Log has all physical modification for the database. And as some folks say, the log is the database. The Redo Log is the core component of the database. And I think that's a good start point to investigate the internals. And I'll explain what I learned. This is the outline of the explanation that follows. At first, I review what is the Redo Log and what is MySQL Redo Log. Then, describe the Redo Log structure and process of physical modification and crash recovery process. Then, I'll introduce how to investigate those architecture with MySQL Redo, which I developed to read and dump Redo logs. At first, what is Redo Log? Most of the database records the modification to the log file for crash recovery. And if database needs to do a crash recovery, it analyzes the logs to extract transaction state when system failure happens, and redo all the transaction or the modification of committed transaction, and undo kind of rollback uncommitted transaction or modification. Then what is MySQL Redo Log? MySQL Redo Log is InnoDB Redo Log, because from 8.0, system table spaces and the data dictionary is fully managed by InnoDB. So, but if you use InnoDB storage engine, that's an exception, because InnoDB storage engine have own Redo logs. But this is my wild guess, but 90% of users are using InnoDB, I guess. So then let's remember the InnoDB architecture in reference manual. Redo log is illustrated here, the below of this figure, and redo log have all modification for the MySQL. Yes, and as stated in the reference manual, InnoDB undo log is not a simple log, and that is a collection of undo log records in undo table spaces. So undo log is not written in sequential log file, but stored like data records in special table spaces. Next, I will describe the basic structure of redo log records. Basically, redo log records has 3 types of data. At the beginning of the record, I call them header. And the first one is the log type. And the next one is space ID. Space ID is the ID for table spaces. And the third one is page number. And as you can see, redo log records are written using space ID and page number as key. And following payload data is formatted depends on log type. Let's look at each log type. The first one is each content of the redo log records. And the first content is log type. And the modification for the table space is logged with mlog file prefix. For example, mlog file create, mlog file rename, and mlog file delete, and so on. Those are recorded as integer number in the source code, but that is assigned with enum. And the modification for the log record are recorded with mlogrec prefix. For example, mlogrec insert, mlogrec delete, and so on. And the redo log is also written for undo logging, and that is recorded with mlog undo prefix. And the byte of modification log type is the most troublesome log type because it's just specify to write a few bytes of data. And that is, for example, mlog 1 byte, 2 byte, 4 byte, like that. I'll show you some example later with those log types. And an interesting point is that there are more than 60 log types in the source code, but there is no commit log type or something like transaction end log type. And the transaction state is written at the header of undo log space. And I'll describe it later. And the next content in record header is space ID. And some space ID for system table spaces are fixed or determined by configuration. For example, data dictionary is stored in the table space named MySQL, the top of the record of this result set. And that space ID is hard-coded. And the space IDs for undo table spaces are defined in fixed range. And space IDs for user table spaces are assigned in order from number 2. And the third content in the record header is page number. Page number is just specify which page in table space is modified. And the remaining payload is formatted depends on log type. Basically, it is that is compose the offset and actual data byte to modify. And those log records are written in group, which is called mini transaction. Mini transaction are written in atomically. And it has divided into 2 log types, which is single log record and multi-log record. And summarizing a mini transaction, physical modification for update statement is this. The first mini transaction acquires undo table space and update the header with the size. And the next mini transaction moves the row being updated to undo log space. I mean, moves before image to undo space. And the next transaction updates the row in place. I mean, updates the overwrite the row with after image. And finally, mini transaction generated by commit operation. Commit operation update the undo log header in InnoDB layer, which is used in crash recovery. And after system failure, InnoDB crash recovery proceeds in order redo, analyze, and undo phase. It's also an interesting point because usually the database book or paper explain those crash recovery process with in order, analyze, redo, and undo. But anyway, in InnoDB, the first phase is redo phase. And at first, InnoDB applies all the redo logs from checkpoint, including transaction state on the undo header. Then, in the analyze phase, InnoDB analyzes all the transaction state in undo headers and extract active transaction. And the third phase, undo phase, roll back all uncommitted transaction. So what is transaction state regarded as, what transaction states are regarded as committed? There are 7 transaction states in the source code, and 3 states means committed in crash recovery. And this one. And this is a simple case with a setting of disable log bin. And if you enable the binary logs as default setting, prepared state are also regarded as a committed if the corresponding binary logs are synced on the disk. And this is a little bit complicated because MySQL uses 2-phase commit between binary logs and InnoDB. So far, I explained the overview of redo logs and what I learned in physical layer. So next, I will explain how to investigate those architecture. At first, I searched the tools to dump and read redo logs of InnoDB, but there isn't. Other databases have those tools. For example, Postgres has PG war dump, and Oracle has logminer or redo dump. And this is my guess, but MySQL uses logical replication. And also, InnoDB is highly reliable, so we need not to take care about InnoDB redo logs, right? But I want to read the redo logs. So I developed a tool to read an InnoDB redo log. The tool is named MySQL Redo. MySQL Redo dump and read the redo log record like MySQL bin log command. And I use InnoDB's crash recovery functions and built as a client command. But this tool is experimental tool, and I quickly built this tool for POC. So the function is limited, and this tool can't decode all of redo log records perfectly. But I will show you how to use MySQL Redo and how I investigate the contents of redo logs. For example, I'll show you the logs generated by an update statement like this. And we can know the start and end LSN log sequence number, which is kind of offset in redo logs. And also, we can know those LSN from global status variables and specify it like MySQL bin log command, file and begin and end LSN. Then the output of MySQL redo command is this. It's so many. I don't examine all of them, all of the record here, but in this output, there is more than 20 log records with 4 mini transactions. And this is generated by one update query, which one affected rows. And unfortunately, almost all log records are written in byte of modification. And there are only 3 log records I can guess the corresponding behavior from log type. We can guess what happened in physical layer without byte of modification log records, but it's better to look at the source codes to be more certain about this. And a good start point to investigate where redo log is written in source codes is added reg method in mtrt struct. The mtrt struct manages to write redo logs as a mini transaction. And there are some functions to write redo logs, but this method is called whenever the redo log records are written. So I set the breakpoint in GDB and investigate the call stack. By reading the source codes, surrounding source codes from stack trace of GDB, I can understand a more certain, more detailed process. In summary, in the first mini transaction, prepare undo space for the transaction and update undo header. And second and third mini transaction moves all log record to undo space and also update the row in place. And the last mini transaction, which is filled with byte of modification log type, updating the undo header. It includes updating the transaction state, linking to the history list to purge, and setting the final transaction number, and finally sets the deletion flag to reuse undo space. So this is my findings. MySQL redo log is InnoDB redo logs. And redo log records are written using space ID and page number as keys. And there is no commit log records in InnoDB redo log, and it's recorded as the header of undo space for each transaction. And undo log is stored like data records in undo log table space, and undo logging are logged also in redo log. And in InnoDB crash recovery proceeds in order redo, analyze, and undo. And wrap up. In this session, I explained the overview of LY Corporation and the overview of MySQL platform in our company and how we manage the MySQL environment. And lastly, I explained the InnoDB redo log, InnoDB Insight from redo log perspective. Thank you.